Okay, can everyone hear me? This is a presentation on a library I developed over the last few months. It's on JSON, and my name is PJ Naughter, and I work in a company called UL on Pierce Street. I'm a Microsoft MVP in Visual Studio and in C++. So the first half of the presentation is an introduction to JSON, so I think we might kind of fly through that. Everyone should know JSON, I hope. And then the final part, or the last half of the presentation, is the library itself. So what's JSON? It's basically XML done right, in my opinion. It's very lightweight. The spec is literally 350 words. And that's one of the reasons I believe why it's so popular these days, because if you were to try and write an XML library, you would have a whole heap of work to do. You'd have to support all the different Unicode variants, ASCII code pages, bombs, by order markers, blah, 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 blah. And, you know, to do a decent job of that, if you're going to do that yourself, well, you're not going to do that yourself. You're going to depend or take a dependency on some other library. So the data types, I'm sure you all know this. You have objects, arrays. The object will be a key value pair. Then a value can actually be basically 7 data types, unlike XML where you have attributes and loads of fun. Yeah, and that's all it can be. There is extensions to that, but that's pretty much the standard. Then encoding of strings. There's a standard for how to put that in valid JSON. And the spec is agnostic when it comes to the definition of how you store a number. It's just a numeric, and your library can do whatever it wants to represent that. So you might maybe have different data types, or you might use an arbitrary precision one. But if you're just using standard C++, the obvious thing to do would be to map it to a double. There's an example. It's one of the samples that my library is based upon. When our company uses an existing library called SimpleJSON, it uses C++ 98. It's all grand, but I thought it would be a good way to learn JSON would be to actually rewrite it or base my library on it, but use modern C++ 11 features. The other thing the library has is JSON pointer, which is kind of a simple version of XPath for JSON. So you could pull out, you know, and it's modeled on the XPath syntax as well, using directory specifiers. There's some simple, it's from an RFC. This is actually the sample data. I think it's actually in the RFC. And there would be some examples corresponding to that. So if you give it an empty string, that actually, you start normally at the root document. So if you give it an empty string, you don't do anything. You end up effectively where you started at. You don't move. If you specify /foo, you'll end up at the foo object. And what you'll get back will be bar and baz. And then for arrays, you can index. And for objects, you can identify the key underneath and so on. And there's a couple of special rules for encoding of the directory delimiter itself and a few other rules, but it's all pretty simple. So so this is the library I wrote. It's basically a C++ header-only library for JSON. That's the link for it there. It's based on an existing C++ library called SimpleJSON, which, as I said, was already being used internally in our company. There's basically one class in it, which is a C value. So I'll show you some code here. Whoops. I can keep on. There you got it. That's it. So it's actually modeled on STD variant. One of the things I might actually do as a future thing, the reason why I didn't use STD variant was at the time I didn't want to take a dependency on C++ 14. I just wanted it to work in C++ 11. And the other thing was I wanted it not to store no memory if you're using a null, the JSON null type. But I think you probably could do something like an STD optional of an STD variant, and you hopefully should have no overhead. So that's something I'm actually going to add or look at adding in the future. So when I was looking at the SimpleJSON library, one of the things that it initially, what it did was it just had all the different types as member variables in its C value class. So you had like a double, an STD string or W string, and you had a bool, and so on and so on. And that meant if you're building this object up in a DOM, then you would be over allocating every object. And then it was then converted to a union, a C style union. But the problem with a union is you can't store a C++ class inside a union. So then it actually went to using pointers to class instances in the union. But the problem with that is cache locality. So the SimpleJSON library as it was using a union of plain data types and then pointers to C++ classes. So the way I've actually implemented it is I'm using an STD aligned union. There we go. Yeah. So that allows you to actually store all the data types. It's basically a C++ version of a struct, of a union, of a C union. So that's cool. So that will allocate effectively an opaque blob of data of the maximum size of whatever one of these objects. So it'll probably be one of them, depending on the compiler you're running on. But that will only allocate the memory for it. The thing you then need to do is exactly like STD variant, is you need to run the constructor at a specific offset in memory to actually create the objects. So if we look at the constructors, there we go there. So this is your copy constructor. So if you're constructing a null, it's not going to do anything. But if you're constructing a string, it's going to run the constructor at a specific memory location. So that's C++ new placement, or placement new, which is cool, great. And the great thing with that is you've got cache locality back. So I always kind of like said, that doesn't affect my code. That's not a problem, but I'll show you some perf values that I actually got when I made that change from a C-style union with pointers to objects to actually having effectively the objects laid out directly in memory. And I was actually stunned by the difference. The other thing it actually does is it obviously uses move semantics as well. And that's the big performance, and especially in a library where you've got kind of a DOM, you're going to have a lot of objects moving through memory and being built up. So there should be, let's find the move constructor. Whoops. There we go. So it takes the object, moves it, and then runs the constructor with that OR value reference in the allocate memory locally and saves the type. The one thing, of course, then is when you're running your operator equal, so when you want to assign a new variable type into your object, you then have to yourself run the destructor. Again, that would, if I took a dependency on STD variant, that would be all handled for me. So I'm going to play around with that in the next few weeks and months. So let's have a look at the operator equals. Whoops. Okay, let's see if we can find. I'm going to stick in string view there as well, which I think is C++ 17. Okay, so let's see. Oh yeah, so there we go. There's your example. So you're doing a move operator equals on a string. So you're going to have to invoke manually the destructor on the object that you currently have potentially, and then you do an std move, use the new placement, and then your usual set the type, and away you go. I'm pretty sure if I looked at the implementation of std variant, it probably ends up using aligned union. So it's currently 1,500 lines of code. I'd imagine if I actually used std variant, I probably could eliminate probably 500 or 600 of that. Okay, so the implementation, you have your parsing. So given a string, create an in-place C++ object representation of that. Currently, I'm only compiling on Windows, or I've only tested on Windows, but I'm only pulling in the C++ runtime. So it shouldn't be a big job to actually, again, that's probably a to-do for me. The only big difference, to be honest with you, would be to use probably std string rather than w string, because the native string type on Windows would be UTF-16. So I might make that maybe a compilable setting so that make that actually you can decide which way you want to do it, and maybe then default it to std string if you're not on Windows. So you parse it. There's two versions, and then the object that the disk pointer effectively will automatically then have your DOM representation. So you can say, what type is this? If you're an object, then you can go into the sub objects and so on, exactly like an XML DOM. Then the other side of it is the encoding. That's pretty much the same as the SimpleJSON implementation. You can't really make it much faster, but the parsing is dramatically faster because of cache locality, std aligned union, and also the new placement. And then you have with the parsing, if that fails, it'll throw an exception with an exception standard exception class, and a reason, and then an index into the JSON where it occurred. So, an unexpected character in a string or whatever, yeah. The JSON pointer functionality, again, basically your JSON pointer parameter, and you're starting off on an object, and what it'll do is give you back a pointer to the object that it arrives at. So it obviously might not arrive at any object, so you get back a null pointer in that case, yeah. It's implemented using standard C++. I'm a Windows guy. I've got a couple of libraries that I run on other platforms, but this one was quite nice in that I took no dependencies on Windows at all, which is good. It's including C string. The one thing I did observe, though, and I think this is going to be a deprecated, the UTF conversion classes libraries in the standard, the performance on them is pretty woeful. It seemed to be a lot slower compared to the UTF-8 to UTF-16 conversions on Windows, but that's not a fair comparison because it handles surrogates and a couple other things as well. And there's a comprehensive set of unit tests as well. So if we just pull up the test program, so the kind of style of code you'd have, there you go. So there's your value class, and it's basically exercising all the methods. So you can return it as a Boolean, you can encode an empty string and so on. So let's look at something more useful. There we go. Another thing I'm going to look at is actually trying to make that, and I believe actually Jason Turner may have already done that in a presentation a couple of years ago, make this const expr. So you could actually have the JSON object parsed at compile time rather than at runtime. But I'm not sure how useful that is, because really JSON is going to be coming over the wire. So how many string literal JSON objects are you going to have? Well, I guess if you're the server, perhaps rather than the client. But yeah, kind of useful. It does also pretty printing on the JSON as well. So, you know, you can get your carriage returns, blind feeds on it, so that it's a bit more readable rather than just being no line feed separators. So the performance. So if we consider SimpleJSON as basically the base implementation, and it went from, as I said, from all the variable types to a union of C++ pointers, just by introducing our value references with the test JSON I was using. Obviously, if you have different JSON data, if it's longer or whatever, you'll get different metrics and so on. But for kind of JSON data of like 200 bytes or so, just by purely introducing our value references and move semantics, it was 15% faster. Then I went to the STD aligned union, and that made it 50% faster compared to SimpleJSON for x86 and 40% for x64. And the encoding is more or less roughly the same, because it's doing the same kind of thing. You can't really optimize that as much because, you know, it's not going to use move semantics. And there's loads of references. So my website, the JSON++ library, blog, email, and there's all the other references, the specification itself. If you've ever read any RFCs, go and have a look at the JSON specification. It's beautiful. Like, anyone can write a library for this. And there's a couple other references. The other thing I will say is that's my library. If you another absolutely amazing library is JSON for modern C++. I did look at that, and it looked amazing, but I could not read the code. And my opinion was, we're not going to use that in our company. It's too complicated for me, I'm afraid. But that's not to say it's good. Rapid JSON. I think I did. Yeah. Again, the product our company produces is a Windows-only desktop application, and I went through quite a few JSON libraries, and a lot of them just did not compile at all on Windows. I don't know if that. I'm not going to blacken that particular library, but I went through quite a few of them. Okay. I may reevaluate that. The other thing I did actually want was simplicity as well. I did not want to pull in. I'm trying to remove libraries from our product, not actually add more. And I didn't really want to take a dependency on a 10,000 line. I know it was a header-only implementation, but I like simple. That's me. And there's a couple of the JSON pointer is an RFC, but there is more advanced query languages for JSON. That's a few there at the end. But again, if you just want basic stuff where you got some JSON coming into you and you want to say dot into this object at a certain offset and then index, you know, the third element down underneath that, JSON pointer is absolutely fine for what you need. And because it's simple, it's less dependencies. I think that's it. So that went pretty quickly. Any questions?
Thanks. So the question is about the use of the align union template.
Yep.
So what practical benefits did you get from it? Because you still had to manually invoke the correct placement new depending on the type of the object when destroying. You still have to correctly call the. You have to manually call the correct destructor. And so on. So how much more complicated would your code be if you just use the naked byte buffer of the correct size to store the larger variant type with the correct alignment instead of relying on the aligned union?
Yeah, I get you. So why use aligned union rather than just allocate a byte array in your object? Well, the size of objects will be different from compiler to compiler. I could pick a value like 512 and it'll always work, but you know, someone will have an extra debug version of a C runtime on a certain compiler somewhere that does sanitization on like values. So the only way I know of to actually get, well, effectively what this is doing is it's doing max size of all of these objects and allocating a byte object or a byte array of that size.
So you're saving yourself from writing some meta programming code to infer the size
like
of the
if
buffer
I looked at the implementation on MSVC here, it'll probably be using perfect forwarding and as we just saw, and it'll basically accumulate a value and give you back a size. So like, why not use that? That's like nice, interesting code. But what I am going to do is I'm going to basically, just from a performance point of view, replace that with STD optional of an STD variant. I don't even know if you're allowed to do that. I hope you should be able to do. And I could just use STD variant, but I want to eliminate the overhead of the memory for when you're storing a null JSON value, because I should be able to. I'm a C++ developer. Yeah, and there's the code to actually run the custom deleter using the correct type. So because you're using placement new, you have to do the construction and the destruction yourself. But if I went to STD variant, it would hide that. Again, STD variant is effectively doing the equivalent of that underneath the bonnet. So
and M storage here is the object of the align union type, right?
Yes, yeah.
So you're basically making an assumption that the actual payload is going to start at exactly the same binary address as the start of the object. I mean,
correct.
The range bit cast there.
Yeah, like that's effectively equivalent to this.
Okay.
I'm going to use a Windows type here, but bear with me. And, you know, a big size. That's what it'll give you, more or less. But the critical thing is, by doing that rather than doing this, so this would be the more naive implementation if you didn't know about STD variant. And this is what I started writing. I was like, this all makes perfect sense. And you stick a bool in there, you know, and then you stick a double in there. This is all simple. That all compiles. And then you stick a C++ object in here. And now that will not compile because the compiler needs to know the size of that type. So that's not compilable. So then the naive implementation is, well, let's make it a pointer. And purely by doing that, and then you're going to have the array object as well, yeah? Sorry, it's array or object, yeah? This here. That's the two types I have in here. So if you do that, okay, you've killed cache locality. I could not believe just by doing that, right? Run the same code side by side, that was 30% slower, or 25%, depending on whether it's x86 or x64. I didn't know. I you know, cache locality I've always heard about, but it was like, that doesn't affect me. It does, especially if you're using an object that's really, really tight on memory and you're trying to optimize it. You could just blindly do this, of course, right? It would be performant, but it would not be memory performance. You could do that. That would be the naive implementation you'd go with. It would be fast, but you're using way too much memory.
Okay, thanks.
Hi. There's a couple of things. Just how does std variant work? How can you, or if you have an optional of was something, and the thing isn't there, do you not still have to have?
No,
is the size of the stuff in memory the size when it's actually there, even if it's not there?
Yeah, you can't actually.
Yeah, but is that not so? It's std optional, and also in std variant. In std variant,
no, the thing with
you'll always have if you tell the variant that you only want say you store a boolean in it, but it's still going to be the same the size of the biggest thing that you can store in it
naively,
all the time.
STD variant will be implemented underneath the bonnet with STD aligned union, because that's the way you asked for a variant, which underneath the bonnet is in the C world a union. So that's what it would give you. That would be how you would naively implement it, right? But here's the thing. I don't want to have any memory overhead for the object if I'm actually storing a null JSON. So in this particular type here, I would be losing 1 byte for every object. So the minimum size for that there, the minimum size would be 1 byte. The maximum size would depend on which one of them, but it's probably, like 20 or 30 bytes or something, yeah? So if I'm storing a JSON null in there, I'm going to basically be allocating 1 extra byte for the object when I don't need to. I'm a C++ person. I don't want that, right? So,
but sorry. In that case, the variant is still going to be the memory allocated for that variant will still be the same number of bytes for the of the largest part of your variant. Is that not true? I've never used variants.
You probably are. Yeah. I probably need to go with. So actually use an STD optional on an STD variant.
Is that not the same problem?
Yeah, it's probably not going to save me. It's just a thought I had in the last couple of days. That I haven't looked at this yet, so that's why I was thinking.
And the last thing I just wondered about your union problem, just using your unions, is the reason that you can't put your C++ object in there that C++ type might have a constructor, and then it can't be constructed properly inside the union.
Yes, I think that is the reason, because I'm doing manually what a union can't do because it doesn't know the type, because it's a union. That's critically, that is exactly the reason.
Okay.
And if you use a pointer, well, a pointer is a pointer. So, but you have to obviously gen that up and destruct it yourself. So you've now taken responsibility for running the constructor and the destructor. So that is the reason. Yes.
Okay, thank you.
But the point there was, I think, that you can actually put a value in your union, just remove the star as long as the thing is default constructible or something, right?
Yes.
Or it's standard layout or trivial layout. Oh. I see.
So actually going with STD variant would reduce the amount of code I use, but it would not, I believe, would not reduce the amount of memory I use. But in MSVC, I'm actually not sure whether I'm certain it's not a C++11 feature, but I've actually compiled some stuff without turning the C++14 or 17 flag on, and it works. But that's probably a very bad thing to do. The product that this will probably be used in, we're probably not going, there's a lot of technical debt in it, and I don't really want to turn on the C++14 flags anytime soon. But that's just our product, that's not this stuff. Okay. Cool.
Thanks for the presentation.